Good morning, my dear students. In this particular video presentation, we'll discuss some more problems meant for students of class 12 of CBSE as usual. The first problem meant for today goes like this. Find the intervals at which y is equal to f of x equal to cos 2x is strictly increasing, strictly decreasing in closed interval 0, pi. Just see here, this is the question. This is the question. Read the question if you want. Now, see, actually I already told you in one of the videos, if dy by dx is strictly greater than 0, the function is supposed to be strictly increasing. If dy by dx is strictly less than 0, the function is said to be strictly decreasing. Just see here, y is equal to f of x is equal to cos 2x. It is given in the interval 0, pi, let us say. Now dy by dx equal to f dash of x will be minus 2 sine 2x. Derivative of cos 2x is minus sine 2x into, for 2x it is 2. It is because of chain rule of differentiation. Let me try to find the roots of dy by dx equal to 0. Will imply you minus 2 sine 2x is equal to 0. Which will imply you sine 2x 0 by minus 2 is equal to 0. But sine becomes 0 at every multiples of pi. But it is 0 at sine 0, 0, sine pi 0, sine 2 pi 0, sine 3 pi 0, sine minus pi 0, etc. But I won't take negative values because the interval given here is between 0 and pi. Therefore, I take it as 0, pi, 2 pi, 3 pi and so on, which will imply I'll end up with anyway 0, pi by 2, pi, 3 pi by 2. Okay, listen, but this does not belong to 0, pi. Therefore, I'll take tabular column like this. Value of x, value of 2x, then value of dy by dx is equal to, there is a minus sign, remember carefully, minus 2 sine 2x, then write nature of f of x. Therefore, you mean to say here 0 less than or equal to x less than pi by 2. Let me take between, even the 0 I need not calculate. I'll start with pi, 2 pi, etc. Therefore, I mean to say this is between 2x is between 0 and pi. These are the values in the first and second quadrants. Listen carefully. Sign is positive in the first and second quadrant, but there is a negative sign. Therefore, it becomes negative. Remember carefully, there is a negative sign here. Now, pi by 2 less than x less than or equal to pi, let us say. Here I mean to say pi less than 2x less than or equal to 2 pi. These are angles in the third and fourth quadrants. In the third and fourth quadrants, because sign is negative, but there is a negative sign. Negative into negative will make it as positive. Therefore, it is increasing. Therefore, from the above table, we conclude that the given function, the function is strictly increasing in, what is the interval? Minus open interval minus pi by 2, closed pi, and is strictly decreasing. Sorry, the symbol here is decreasing in close 0, open pi by 2. Decreasing in 0, pi by 2, increasing in pi by 2, pi. Let me just explain the whole lot fully. Let me just take dy by dx. It is minus 2 sine 2x. dy by dx 0 will imply you sine 2x 0. I am not bothered about 0. I'll take pi, 2 pi, 3 pi. Dividing by 2 throughout, I get pi by 2, pi, 3 pi by 2. But 3 by pi by 2 is the quantity beyond pi. Therefore, I take only these two values. I'll take a tabular column like this. Value of x, value of 2x, value of dy by dx. There is a negative sign in dy by dx. Remember carefully. And nature of f of x. This is f of x. Nature of f of x. This is x. Sorry. Nature of f of x. Here it is between 0 and pi by 2. Includes 0, exclusive pi by 2. When x is between 0 and pi by 2, your 2x is between 0 and pi. 0 to pi are angles in the first and second quadrants. You know very well the rule all silver teacups. In the first and second quadrants, sign is positive throughout, but there is a negative sign. Therefore, dy by dx will become negative. When dy by dx is negative, function is decreasing. When x is between pi by 2 to pi, inclusive pi, 2x is between pi and 2 pi. But pi to 2 pi are angles in the third and fourth quadrants. In the third and fourth quadrant, sign is negative, but there is a negative sign in dy by dx. Therefore, negative into negative make it as positive. Therefore, its function is increasing. Dy by dx is positive means function is increasing. Therefore, function is strictly increasing in pi by 2, pi, open pi by 2, closed pi. Pi by 2 is not included, pi is included. And strictly decreasing. The symbol I wrote it wrongly, I corrected. In close 0 and open pi by 2. This is how the conclusion is given. It is not at all difficult just to recall the rule. Dy by dx is strictly positive if and only if function is strictly increasing. Dy by dx is strictly negative if and only if function is strictly decreasing. Remember carefully. Dy by dx is positive implies it is strictly increasing. Dy by dx is negative implies the function is strictly decreasing. Remember that rule carefully. Having that rule in mind, I think you'll be able to do this sum properly. Then next question goes like this. You are given a is equal to 1, 4, 5, 6, 8. A is 1, 4, 5, 6, 8. Okay, a relation R on A is such that A or B, finally, if mod A minus B is divisible by 10, show that R is an equivalence relation. See, this is the question given to you. This is your question. This is your question anyway. See, read the question if you want. Okay, see here, I'll just do mod A minus A is equal to 0 is divisible by 10. Divisible by 10. Okay, 0 is divisible by every number except 0. Therefore, A comma A element of R for every A element of A. Therefore, R is, this rule is called reflexive. Let A comma B element of R, which implies mod A minus B is divisible by 10. Therefore, let me think about mod B minus A. Mod of minus of A minus B, which is equal to again mod A minus B, which is divisible by 10. Implies B comma A element of R. Therefore, A comma B element of R will imply you B comma A element of R for any two A comma B element of A. Therefore, R is symmetric. This is the real meaning of symmetric nature of the given relation R. Let A comma B, B comma C element of R, which implies mod A minus B, mod B minus C, or divisible by 10. Multiples of 10 divisible by 10, both are same. Mod A minus B is 10k. Mod B minus C is 10l. K comma L element of n. They are positive quantities, therefore I take it as n, which implies A minus B is equal to plus or minus 10k. B minus C is equal to plus or minus 10l. Therefore, add these two, A minus B plus B minus C is equal to plus or minus 10 into K plus L I have, which implies mod A minus B is equal to 10 into K plus L, which implies A comma C element of R. Therefore, I can very well write A comma B, B comma C element of R implies A comma C element of R for any three A comma B comma C element of A. I don't have space, therefore I am just dictating. Write that statement. Therefore, R is transitive. Therefore, give the conclusion at the end. R is reflexive, symmetric, transitive. Therefore, it's an equivalence relation. Just by taking a simple example, I won't be able to say it is reflexive, symmetric, transitive. Example can be given only to negate a statement. Only to negate a statement, not to prove a statement. Just to prove a statement, I should not give examples. Remember carefully. To prove a statement, always we should give a general proof like this. Let me just repeat the whole process. I mean to say, mod I minus a is equal to 0 is divisible by 10. Therefore, a comma a element of for this symbol is called for B crossed. It's called for every a element of a. If it is not clear, I will just write down again. This is for every. The symbol is called for every. Okay, for every. V crossed is the symbol used for every. Okay, that's the real meaning of function relation to be reflexive. Let a comma be element of R. Therefore, mod a minus b divisible by 10. Therefore, when you think about mod b minus a, mod b minus is the same as mod a minus b. Mod minus 1 is 1. Therefore, they both are equal. Therefore, mod a minus b is already divisible by 10. Therefore, this is also divisible by 10. Therefore, a comma b element of R implies b comma a element of R. For any two a comma b element of a, therefore R is symmetric. Let a comma b comma c element of R. Here mod a minus b mod b minus c are divisible by 10. Mod a minus b is multiple of 10, mod b minus is multiple of 10. I'll write it as 10k 10l kl element of n. Therefore, remove modulus and then add. That's very, very essential. I can't add within the modulus. I have to remove modulus and add. Adding which b gets cancelled. Sorry, there is a minus sign here. I wrote it at plus c. Sorry. There is a minus sign. Okay, here for mod a minus c is 10 into k plus l. Mod a minus c is also multiple of 10. A comma c element of R. For any three a, b, c, a comma b comma c element of a, this result is true. Therefore, I come to the conclusion R is transitive. Therefore, give the conclusion R is reflexive, symmetric, transitive. Therefore, R is an equivalence relation. This is how you are supposed to do. If the numbers are limited, if you are able to list the elements, that is well and good. It's up to you to do, but if the list is very big, better to do like this. Okay, I can write 1, 1, 4, 5, 5, 6, 6, 8, 8. What are all the possible elements in R? If you are able to list all the elements, it is meaningful. But still, giving an example and proving that it is reflexive, symmetric is not at all correct. Remember carefully. Okay, therefore, general proof like this will be always easier to give the answer for such problems. But need not be divisible by 10. It can be divisible by 100, divisible by 25, divisible by 12, divisible by 15. For anything, the method will be always like this. And only for transitive part, remove the modulus and then add. That will be the easier way to prove a comma c is also element of R. Therefore, again in this particular problem, learn the rule behind the whole lot. Instead of 10, I can be 100. Instead of 100, I can be having 12. Instead of 12, I can have 15, something like that. Okay, learn the rule. It's easier always to do any problem of that type. I'll check for the calculations. If there is any error, I'll just add up. Otherwise, I'll upload as it is. Thank you, students, for patient watching.